Hey everybody, happy Thursday. Okay, so today we're going to learn about acids, bases, and their conjugates. You guys may have heard that word conjugate before, like conjugate verbs in Spanish class, maybe. So this word's kind of similar. So here's what it means. Let's go to the dictionary here. Conjugate. It's an adjective, but we can kind of use it as a noun. So, or I guess it's a whatever. Joined together, especially in pairs, coupled, like a conjugate relationship, acting or operating as if joined. Okay, so that's nice, but here's the one we really like: having features in common but opposite or inverse in some way. Yeah? So that's kind of what we're looking at. They have something in common, but they're opposite or inverse in some way, these acids and bases. Because after all, what do acids do? And what do bases do? You're never going to forget again because they're bad. Yeah? Bases accept protons, which is hydrogen ions, and acids donate protons, which are hydrogen ions. So here's what this was our example last time. We had hydrochloric acid combining with water to form a chloride ion all by itself and a hydronium ion, which is a new ion we just learned, polyatomic ion. So what happened is HCl, think of this arrow as everything over here is before the reaction happens, and everything over here is after the reaction happens. So before the reaction, this chemical had one hydrogen, and after it had no hydrogens. So the number of hydrogens went down by exactly one. And here with the water, the number of hydrogens went up by exactly one, because it started with two hydrogens and it ended up with three hydrogens. Yeah. So this chemical right here is the acid because it lost a hydrogen. And who loses hydrogens? Acids do, because they donate them. Yes. And this chemical right here, the water, acted as a base because it accepted a hydrogen. Bases accept, acids donate. So it started with two hydrogens and it ended with three. So between here and here, it accepted a hydrogen. Yes? Okay. Well, I haven't told you guys this before, but I'm going to tell you now. Chemical reactions aren't just one way. They can actually go back the other direction. So I'll show that like with a dotted red arrow right here, showing that that reaction could go back this direction, meaning this hydronium right here could become water. And how could it do that? That's right. It could do that by donating a proton. See that extra H plus right there? It could give it to the chloride right there. So this hydronium could, if the reaction went backwards, act like an acid. So what we call this hydronium is a conjugate acid. It could potentially act like an acid if the reaction went back the other way. And this chloride right here could act as a base. It could go from chloride to hydrochloric acid. So it could accept a proton. And who accepts protons? Bases do. So that would be a conjugate base. Yeah? Okay, I know that's a little bit confusing, but we're just going to do some practice, and in so doing the practice, you're going to get it. So here we go, right here with some practice. So I'm going to give you guys this worksheet right here, and if you have a printer, then you're lucky. You can go ahead and print it out. I don't have a printer. I just had to dig this one out of an old notebook that I got. So if you don't have a printer, you can just look at it on the screen and do it on a separate piece of paper. So a lot of this stuff is from last time, like what's the difference between a hydrogen ion and a proton? Nothing. This one's the crucial one right here. How do you tell which chemical in a reaction is behaving like an acid? Well, you remember that bases accept protons and acids donate protons. So what you need to do is look at this sucker, and if you just look right here, you can't tell if it's acting like an acid, a base, a conjugate base, or a conjugate acid. It won't work. You have to look at it before the reaction and after the reaction. So this is the same chemical after the reaction. And if we look, two things happened. The first thing is that it went from having 4 hydrogens to having 3 hydrogens. Yeah? So it lost a hydrogen. The second thing is that the chemical went from having a +1 charge to having a neutral charge. So it lost a hydrogen and it lost a positive charge. So the combination of a hydrogen and a positive charge is a proton. And who loses protons? Acids do, because they donate them. So this is an acid. Yeah. That would mean that this chemical would be its conjugate base. What happens to acids? They become conjugate bases. You don't really have to think of it more than that. Okay, this chemical right here starts off with 2 hydrogens and it ends up with 3. It starts off with a neutral charge and it ends up with a positive charge. So this chemical accepted a proton. And who accepts protons? Bases do. And when bases accept protons, they become conjugate acids. Yeah? So how do you tell which chemical in a reaction is behaving like an acid? You look at it before the reaction and after the reaction. If a chemical behaves like an acid, it becomes a conjugate base. Okay, that's good. I'll leave those ones up to you. But I want to do this one with you guys down here. So you guys can do these ones. Identify the acid, the base, the conjugate acid, and the conjugate base, just like we did that. And then go ahead and fill this one out because that's going to help you a lot thinking about this one. These ones are going to be hard for you unless I explain how to do them, which I'm going to do right now. So what's the conjugate base of the following acids? So it's telling us that they're acids, which is nice. What do acids do? I don't remember. Oh yeah, I remember. Acids donate protons. So in order to make this into a conjugate base, I need to take away 1 hydrogen and I need to take away 1 positive charge. So if I take away a hydrogen, this thing becomes ClO4. And if I take away a positive charge, then it goes from being neutral. See how there's no charge up here in the top right-hand corner? It goes from neutral. What's 1 less positive than neutral? -1, like that. So all you have to do is take away a hydrogen and take away a positive charge, and you'll get the rest of those suckers. Yeah? Okay, then go ahead and do this one. That's going to help you out a bunch. And then what is the conjugate acid of the following bases? So now these are bases. And what do bases do? Go ahead, tell me. What do bases do? Don't wait for me to say it. What do bases do? Go ahead and look up here. Bases accept protons. They accept protons. So if this is a base and it accepts a proton, then it's going to get an H added to it. HCN. And then if it starts off with a negative charge and it accepts 1 more positive, 1 more positive than -1 is neutral. So it's going to go from having a charge of -1 to a charge of neutral hydrogen cyanide. Yes. Okay, so you guys can fill that sucker out, finish this, do it, and we'll do a quiz on Friday. Does that sound good? So on Friday, I'll give you the key for this sucker and maybe go over some of the answers with you guys. You guys can ask me questions, text me 805-801-3186. Ask me if you got any questions, and we'll just take that quiz on Friday. Does that sound good? Sounds good to me. You guys are doing such a good job in this chemistry class. It's learning. You want to know what? I'm hecka lucky I got you guys and not a bunch of bozos. I got stoked on this whole thing. You guys are stoked. I'm stoked. Miss you guys. Adios.